Assalamualaikum.
Assalamualaikum ভাইয়া।
ওয়ালাইকুম আসসালাম।
আসসালাম ভাইয়া।
স্যার ভালো আছেন?
এই তো ভালো আছি। I think I made a mistake. I put it in admit. I should have taken that out because I don't want to be admit. I'm going to give Shohag, make you the co-host so that you can admit people.
All right, sir. Thank you, sir.
Shibu is here. Good morning, Shibu.
How are you? Good morning, everybody. Good afternoon.
Hi, good morning.
Good afternoon.
Hold on, I gotta make Shibu co-host, and I'm gonna make Lijan as well co-host.
Yeah, good morning, everyone. Good morning, Mo. Good morning, Shivu, star of the show. Hope everyone is doing great today.
Yeah, I'm gonna tell one story though. Lijan needed to certify one more thing or two more thing or whatever it is that he needed to do. He just finished like freaking 3 certification in 2 weeks. I don't know what the hell you guys are doing. You gotta learn from Lijan.
You know, when you work for Mo, I'm reporting to Mo Saman, so he put you under the gun. So he asked me as soon as I joined his team, why don't you complete 2 more sets you're remaining? So that's what I did. So Mo
So
is
now
very
he has
all because of you.
13 certification, all of them, all in AWS. Okay, so what I'm gonna do, let me check one more thing and then we'll jump right in. Do we have all the people who signed up? Looks like that we have how many people? 24 people. If you don't have signed up yet for the lab, I'm just gonna post that in the chat window. For the lab here. At the end, I'm gonna let Shibu start. But if you have not signed up for the lab, please go in here and sign up for the lab. Make sense? Are you guys all signed up? It looks like that you might have been signed up already. Okay. That's perfect. Perfect. Okay, so why don't we jump right in? And I'm going to hand it off to Shibu. So there is a few things that we talked about. A lot of time machine learning is very complex. And I got a lot of feedback from you guys, like, you know, we're jumping right into too much details and hands-on. We don't even understand basic stuff. So we're going to go differently. We're going to go, you know, to some extent, start from very basic, slowly, but make sure you understand, and we're going to possibly repeat that. Now, I asked Skill University to do that so that we're going to be making sure that you have access to this thing even in future. Because last time we didn't record it, we didn't go through the Skill University program. You can sign up in a Skill University program as well and visit that. These are free for you. And you will all have access to the labs right after that. So just a format wise, almost at the end, I would say maybe 15 minutes before, you should do a survey. And we're gonna post that survey. Make sure that survey is, you have filled out that survey, just so you know, because that's gonna be extremely important. And Lijan is gonna post the survey link in a moment. You don't have to do it right now. We're gonna remind you at the end after the session. Make sure that's extremely important for us, okay? All right, with that, let me just hand it off to you. Shibu, it's all yours. Shibu, did I make you a host, co-host or something?
I don't know, but I really would like to share the screen, but I'm not seeing an option to share the screen right now.
You don't?
Oh, I got it.
You can't share?
Yep,
can you?
I can share it now.
Okay. So if you can share, perfect. Go for it. And I'm gonna let Mahmudur manage the admit, and Shibu, it's all yours, my friend. We see a wrong screen though. We see the speaker note screen.
Swapping it. I think everybody can see the machine learning ML journey screen. All right, so let's start. Good morning, everybody. Hope everybody is doing great. So just show my face for now, and then I will probably turn off the video for the bandwidth issues. I don't want to be chalk this. So hope everybody is okay with that. Let me find out that video link where I can turn it off. All right. All right. So good morning, everybody. One more time. Good afternoon. So remember, we have a call last couple of months back, I guess, right? 2020, November or December timeframe on machine learning. So I don't know how many of you attended that. So hope you get a jump start on ML already, and what AWS offer in that space. And on that meeting, on that 2 or 4 hour session, we talk about how Sagemaker works, how machine learning is going to make a change, how easily you can get into data science world. But we didn't talk about the basics. So we provide the tools, but you don't have the fundamental core knowledge. But I'm not saying that not everybody have that knowledge, but I know that there are a couple of guys we were talking about ML in depth. So somebody is doing some research on that. That's really great. So, so I was thinking about, along with Mo and Lejan, how we can change the perception if you are intended to get into this ML journey, right? So why machine learning? That's the first and foremost thing, right? So over the past, I would say past 4 decades, or more than that, or probably 5 decades. It's probably started in the 1970s. There are machine learning is started, but machine learning is nothing new. It's been there. So many algorithms being found out. But why it is not penetrated, or why it is not being used in the industry, is because of the compute power. Things has been changed. So compute power has been that exponentially grow over the period of time. And along with the compute power, storage become cheap. So technology really did a big jump over the past 2 decades specifically. And over the period of last 10 years, machine learning has become a kind of a norm, right? And people are started adapting it. And one of the reasons people are adapting that one is to make a change in the human life. So if you really look at it, many of the areas which we are working on, it one or other way, machine learning is making an impact. Starting from the recommendations you are getting when you are going to Amazon or any other e-commerce site, where something similar to the music selections, and many areas. I mean, it's even in medical field. So I don't want to go and get bored, making you bored with that. But the plan is, today we'll be talking about taking a step back and helping the folks who are interested in machine learning. Let's start from the basic. What is really need to start that journey in machine learning, right? It's never too late. It's still around less than 5% of the industries is still mostly adapted machine learning. So there are a lot of growth potential ML technology has it in the future. So let's talk about what is machine learning, right? So start with the definition. So what that means is, so you are programmers, I guess majority of you guys write at least a couple of lines of code in your life, right? So in a normal programming paradigm, right, when you are writing a few codes, that code is actually getting some inputs and producing some outputs. But when you're writing that algorithm, I'll call it as an algorithm because it is, it's a logic. It's a certain set of logic you write it. So you get that input data and create some instructions inside your functions and process based on certain business rules. So in that kind of arena, you are actually taking only certain set of data and working on that certain set of data, and you have predefined rules on that data. And based on that rules, you define an output, right? That's what we usually do, right? Very important keywords here is the data, right? And the another important keyword is instructions. And another important keyword is variables, dependent variable and independent variable. So let me take a detour here, right? So we talking about this algorithm. So think about this algorithm is an experimentation. You're doing some experiments. So when you're doing an experiment in labs, you are actually taking certain elements and certain things and doing experiment with that. But when you're doing an experiment, you always keep certain things constant and you change certain things, right? And then you will be seeing an output based on that. So if you really look at it, you can see that correlation between these things which you used in an experiment, and you come up with an hypothesis, right? And that hypothesis, very important, right? Not 100% certain. There's a probability you are actually saying, hey, based on this experiment, this is what I'm going to predict, right? Very important point. So coming back to our starting conversation, when you write that programming paradigm, right, in an algorithm, right? So you have certain instruction, you write certain rules, and use certain output. But when it comes to an ML algorithm, right? So we call this program, right? What we wrote right now, we will call it as call a model, right? So a model based on certain experiment. So we did some experiment and we come up with an hypothesis, right? And we call this, the entire thing, we call it as a model, a machine learning model. So if you really go to the nitty-gritty details, peel the onion, you will see that this is nothing but a program, right? So that program, what it does is it's going to take data, right? And start learning a behavioral pattern, right? Or a certain pattern, could be behavioral or could be a predefined pattern, or a potential pattern can be happen. So it's pretty much learning a pattern out from the data. So if I ask you a question, what's the most important thing in machine learning? Unmute yourself and talk. Let's make this an interactive session. It's going to be fun. Anybody can talk. Anybody can tell me what's the most important thing in a machine learning?
Yeah, you can type in the chat. তোমরা যদি চাও চ্যাটে টাইপ করতে পারো অথবা আনমিউট করে
training data.
Getting data, right? Data is the most important thing. Without data, it's completely useless, right? So we cannot find a pattern. So data is the most important thing, right? So that's the reason I actually talk about this so far. We need to go to the basics. So we need to go to the data, right? So now, let me go to the next slide. Let's start with the basic. That is nothing but data. So we'll start from the basic, right? So when we talk about data, there is a, I would say it's a brothers or sisters or brother or sister relationship here. Two things coexist in machine learning world. The machine learning is one part of it. The other one is big data, right? Or we can call it as a data, right? So the data analytics is the fundamental or foundation, I would say, before you start data science. Data science. So science about the data, right? So the data is most important. So data analytics is also important. But I'm not deviating the topic. I don't want to ask you to go and learn data analytics, but if anybody has interest on data analytics, more, it may be a good idea. We can, a different stream we can start later on data analytics as well. That may be something which we can do as well. It's really important. So I will leave that up to Mo and Skill University team to think about that perspective of data analytics stream, which we can educate the team members on data analytics as well. So people will be having interest in different areas. So some people will be having more
Shibu,
interest.
just to make sure that I understand, you're talking about separate session for analytics, how we do analytics versus machine learning?
Absolutely. Okay. So separate session for analytics, a separate stream altogether.
Perfect.
So these two are my passion too. When I started with data analytics, my career started around in 2010 as a manager in data analytics world, and I was head of the data engineering team in KPMG earlier. Prior I joined to AWS. So then I started my machine learning journey. Then I came to know that the strength I actually gained over the period of time in data analytics, how much it helped me to get my journey, make it faster in machine learning. So data analytics is really good in that perspective, but it's not mandatory. We can create a line between these two. There is definitely a line between those. So when we comes with the data, so data analytics, as I said, is one of the core part of it. So the reason for that one is before we get into feature engineering. So let me take a step back here and go to this slide. This is really important. So this is going to be illustrate why the data is really important to solve a machine learning problem, or how we can frame the machine learning. Before we solve it, let's frame it. That's really important too. So let me take a step back and talk about where to apply machine learning, where not to apply machine learning, right? So there is whenever a new paradigm coming in, people have a common tendency to adapt it and start diving into it. And everything is going to be solved by machine learning. Wrong perspective. It's not a good idea to do it. Right. So when to learn machine learning is when you don't have a certain rule, when you didn't find a certain rules can be applicable, right? And you have tons of data, a lot of data, and we cannot identify a certain pattern out from that. And then you really want to get an outcome out from that with a probabilistic theory. That means not 100% sure. 100% is that guarantee? No, it's a 99% accuracy or 99.9% accuracy. My prediction can be done. But you can take that 0.01 error rate. It's okay to take it. That kind of situation, machine learning is applicable. But there are certain stages. If you are going to take that risk of 0.01, especially in medical field, there is a human intervention can be happen in this case. We call that as an A2I, augmented machine learning. Augmented machine learning. So they're actually man in the middle. So we are going to find out what is that a 0.01 error accuracy and going to check it, whether it is going to be rectifiable or not, or it's going to be what machine predicted is correct or not. But coming back, so when we are actually framing that machine learning problem, we really need to find out whether is that something which is really need to solve it by machine learning or not. That's very important, right? So if we find out, okay, we have a lot of data and we don't have a certain set of predefined rules and we cannot write a program based on that predefined rules, then that is something which we can think about a machine learning problem can solve it. But when we start the machine learning problem, we really want to, as we spoke about, data is the most important part. So it starts with the data collection. So when we start framing that machine learning problem, the first question you are going to ask, if you are going to build your own or you are become a consultant and work for another company or your own company. So first question you ask, do I have enough data to do this work, right? So the second thing is how I'm going to collect this data. For example, sensors. We have a lot of sensors around a factory, think in that direction, and IoT basis, Internet of Things, right? So we're collecting that data. So do we have a data collection mechanism? Yes, we know that there is a data coming from sensors. The second thing is you have a data collection mechanism, right? So the next thing is to integrate to the data, or transforming and integrate and preparation and cleaning of this data. It's all really important. So all those blue things here, so data collection, data integration, and the data preparation, you can even further enhance this called data augmentation. For example, you take a lookup data and you augment your data collected with that data. For example, you are collecting windmill data, and then you collect the weather data, right, from an external source, right? So that you are augmenting your windmill data with your weather data, right? You are going to find a pattern there, right? So all these parts are actually part of data analytics world. Even though it's like 3 or 4 boxes, it's a tons of work going to be happening in that case. That's the reason data analytics is really important. So we need to create data injection pipelines and data quality checks. And big part of is data governance and data auditing, master data management, multi versions of truth, single versions of truth, and so many stuff, right? So those all coming under data analytics world. And once you secure the data and you check the qualities and all that stuff, great stuff. And the next is we are actually taking a small set of the data and visualize the data, right? Why we are visualizing it? We need to find out whether this data has any anomalies. Is anything is missing in this data set, right? So is data is in the right format? So I'm going to talk in detail about this one in coming slides. So all that is actually part of data visualization analysis. So once the data visualization happens, then we came to know that we need to create features. So features is nothing but data points, right? So if you really look at a table structure, when you create a rows and columns, right? So think that every column has a dimension. You can call it as a dimension, or you can call it as a feature, right? For example, we call it as a student ID, and the student has a feature, or I would say attributes or dimensions. Can be gender, it could be marks or height or weight or activities they do. All those are actually features, right? So for example, if you take a song, the genre, the artist, when it is released, all those are actually features of that specific song, right? So then based on that, we'll be creating predictions and such things, right? So those are actually features. And what is feature engineering is actually we are processing that, right? And find out when machine learning, the speciality of that one is we cannot provide, not all the machine learning model will take characters. You need to convert that as a numeric. And sometimes some of the features we need to combine together to create more meaningful. Sometimes we need to break that, right? So we'll come to that in future slides. So all that is actually part of the feature engineering. A lot of stuff we are going to do before we are going to enter to the machine learning world, or machine learning or real work we are going to do. A lot of prep work. And that is actually based on the survey, it is around 60% to 80% of the work a machine learning scientist or data scientist is doing is data prep work and feature engineering work. That's a tons of work we are actually talking about, right? So that's very important. So in today's session, we will be concentrating on feature engineering. So we will be going a step-by-step basis here, right? So what are the things which is really important about feature engineering, the basics of it? So that's what we are going to talk today. And then the next thing is model training and program tuning. So when we talk about model training and program tuning, we need to talk about different varieties of algorithms, what is different ways like supervised, unsupervised, reinforced, and then we break that out to shallow learning algorithms, deep learning algorithms. So what's the difference between these two, and where we need to apply the deep nets and such, right? And then we'll be going to the little bit more detail about it. So what is involved in model training? What is parameter tuning needs? And we talk about that in the coming sessions. And then we talk about when we have that, the whole idea about feature engineering, model training, and parameter, then we talk about how we are going, we have a model at that time, right? then how we are going to evaluate that model? Evaluate that model in two phases. When we have a model that has to be evaluated before we put that into production, right after the training, right? And then the next step is, once we put that in the production, how we are going to evaluate it in a real-time inference, right? So we have a hypothesis is ready, and we tested, everything is good, and we are actually getting the input, and we are actually producing an output. So we need to make sure the output, what we are producing, what customer is really wanted in that way, customer happy with that, very important. I'll give you an example. In fintech world, you guys probably know about the target fund, right? So for example, in pension world, 2040 Vanguard fund, right? So when a target fund, what they do is you take your input as 2040, and they will be asking you many questions. I want to go to the detail, but it's called robot advising, right? So why is a robot advising is a person will be there. So sometimes it may not be having a person at all, throw you a bunch of questions and getting an answer from you, right? And based on that answer coming from you, basically it is when it's actually getting an answer from you, it is pretty much creating a feature set, right? And then based on that feature set, it's going to provide you a portfolio by which you can be retired by 2040 with your certain target in 1 million or 2 million or whatever it is, right? So when we provide that kind of output, it has to be to a certain level of assurance we need to provide to the customer, right? Over the period of time, if that assurance is not there, right, the people may not come to your firm to buy that kind of targeted fund, right? So that model evaluation is really important. So when I go through this, the whole cycle, I will be telling you what are the AWS services which you can use it over your journey, right? So then we'll talk about monitor and debugging. So that is actually essential part of the programming paradigm. When you come from programming paradigm, you know that how we are looking at monitoring and debugging of it. And then, deployment is definitely a part of deploying a model into production for inference. So this is the basic workflow of a machine learning cycle. And so why it is a cycle? When you're getting a prediction or when you are getting inputs from your customers, when your model is working in production, those are actually new inputs. We need to feed that back to our data collection here. And we need to retrain our model based on the new input. More and more data is going to be, or not just same kind of data, varieties of data. When you comes in, your model is going to get better and better. Its efficiency, I would say its accuracy or prediction ability is going to be increased. So that's the reason it's always a vicious cycle here. All right, so I'll take a pause. Any questions on this? Unmute and please talk. That is going to give the vibrance to our class. No questions? All right. So let's, let me ask you this, right? Instead of asking you have any questions, any suggestions? Are we in the right target? Are we in the right track? Everybody happy with this journey so far?
Yes.
All right.
Yes.
All right, that's great. So let's talk about feature engineering right now. So we talk about data exploration and preparation. Right?
Hi,
Yeah.
Sorry, I had a confusion. So in the previous slide, we had model debugging after production or before production deployment.
Oh, that's really good question. So it can be happen both sides, right? So majority of the time debugging will be happen prior to production. So we debug it, we will find out. So basically what exactly mean by debugging in that case is it's not a program debugging. It's a little bit different. So when you have a program, you step over and find out what's the variable assigned, right? So that's what we usually do in a debugging world, right? It is a little bit different. So machine learning, well, when we are debugging it, so we are actually looking at what kind of drift is happening at the time when we are actually receiving new variables in a model prediction. Or it could be, that is actually a post-production, that's more towards drift and bias detection at the time of prediction time, right? And the debugging time, so where the good example is, I'm actually jumping over the loop right now, in a gradient descent world, right? When we are actually looking at that learning rate and such. So when we're looking at it, where is a vanishing gradient will happen? So if I say that vanishing gradient, I don't know how many of you guys understand that, but we definitely go to the next session. We'll talk about the gradient, and when we can talk about vanishing gradient, it's going to be a common problem, right? In debugging, we can find out why that vanishing gradient issue happens and how we can prevent it. That happens before we deploying the model. And the bias detection and variance detection, that can be happen after the deployment. That is actually a real-time monitoring. So this can be here, and this can be here too. Does that answer your question?
Yeah, thanks.
Okay. All right. Keep asking questions, please. Let's make that interactive. Unmute and talk. All right. So let's talk about data exploration and preparation. So there are various steps. It starts with variable identification. So when I say that variable, right, so we'll be going to the root, right, the fundamentals, right? So variables is nothing but feature in this case, but it's not really become a feature. So we look at the data points at this time and make sure whether is that something which I can qualify as a feature or not. That's our discretion, right? So for that, you need to have a basic functional knowledge. So if you are going to be in a FinServ industry, so you need to know some fundamental basics of it. For example, you are in FinServ, you are in a credit card industry. So what's the behavior of a credit card holder? So what's the variables which is associated with a credit card? Things what can be changed and things cannot be changed. So you need to know a little bit functional knowledge, not a little bit, a pretty decent functional knowledge about it. But that gaining that functional knowledge is not too tough. People will be there when you are going to get in your job. They will be helping you to gain that functional knowledge over the period of time. But if you have that fundamental knowledge of how to do things in a technical way, things will be much easier for you, right? That's important thing. So we start with the variable identifications. So variable identification, actually identifying that predictor input. That's a predictor, that's the input. And then we'll find out the target, what's an output variable, right? So the next is identify the data type and the category of that variable. That's really important, right? So then comes to univariate analysis. So univariate analysis is going to be take one variable at a time and analyze that variable. What kind of variable it is, what kind of data type it is, how it is going to be changed over the period of time, how its data being skewed or not skewed and such, right? And then comes to bivariate analysis. Bivariate analysis means we are actually looking to take two variables together or multiple variables together and how they are correlating each other. If X goes up, what is the behavior of Y? Right? If age goes up, the IQ goes up or not? Is that a strong correlation or a weaker correlation, right? Or if a height goes up, if a batting for cricket, a person who can bat ball, is that directly correlated with height or not? That's another study. So that is actually called bivariate analysis, the correlation and the correlation between the variables, how strong that correlation and how that tendency vary and such. I'll go in detail all of these boxes. And then called missing value treatment. So when we are collecting the data, the data points can be missed multiple reasons, right? Could be by mistake, could be some data injection pipelines that your data analytics guys did it. So you need to go back to them and say that, fix it. So then if we cannot fix it, how we are going to adjust with that? What's the technique we need to do it? How to do that missing value treatment, very important. The other one is outlier treatment. So when we are collecting this data, the data can be skewed one way or other. Sometimes, not only skewing, sometimes it's going to be outlier can be happen. Like all the data is coming between 5 and 10, and one of the data is going to be 100. It's going to be entirely ruin the entire data set. It's going to be all these things, right? Happens. It's going to be affect the predictability or effectivity of your model, which you're going to create in machine learning. That's the reason this is really important. And then we talk about variable transformation, how we are going to transform the variable, right? We'll transform the variable in the sense sometimes you need to combine the variable or sometimes you need to break the variable. In the sense of, for example, you have a month, year, and date, right? It's a date. So 02/01, 2021, right? So you can break day of the month, right? Month of the year and the year part. And then you can find out certain things will be changed on some days. Sales are increasing. Maybe Saturday, sales are increasing. So how we can get that conclusion? By breaking those variables. So that's really important. So that's a variable transformation. And then variable creation, that's another important thing, right? So you have length and width of a room, and then you can create a variable out from that square feet, right? So that is actually a variable creation, just a quick example. So all these points are actually part of the data explorations and then preparations. So let's take an example here, a student ID. So this is going to be a table. We are considering it a student ID and a gender and a grade, height, weight, and whether they can play cricket or not, based on this data. So there is no, I mean, if you really look at this table, we cannot create a program or a certain specific rules based on this. So we are going to identify a general behavior, right, by creating a machine learning model and put these features to put this input to that model and find out whether that person can play cricket or not. Think about this way. So that's what we are trying to do. So we call these are actually different variables in this case. So we call it as a feature, become a feature later on. And we probably sometime you drop it, some of the stuff, right? So think about this one in your mind and the future explanations. So here we talk about a couple of things, right? So we talk about variable types, data types. Oh, I repeat that. Actually, it's variable category. Okay, this data types is variable category. Copy and paste issue. My apologies. So variable types. So it's we call it as a predictor variable. So think in this case, what are the predictor variables here? What are the target variables? So if you really look at here, our predictor variables are gender. It could be grade. It could be height. It could be weight. So those are actually our predictor variable. Those are actually inputs. And what's our output here? Whether that person can play cricket. So those are actually the variable types. So when we take out the variable types, there are two type of variable types: predictor variable and target variable. Very important. So when you go into the machine learning world, so you would be doing this one day in, day out, especially in supervised algorithms or non-supervised. So you would be having that, what is a predictor variable and what is a target variable, right? Then we will move to the data types. Data types, this is pretty much same thing which we look at in any program data types: characters, numerics, and can be more than that. Booleans are another one. So here in this case, you can identify what are the character variables here, what are the character data types, and what are the numeric data types. So if you look at the table in the previous example, right? So you can see that student ID, that's a character because it's an S in the front. So it's a character. And then you have a gender, that is, again, it's a character. And the grade is another character. But play cricket, height, and weight, those are numeric. Why I'm saying this, actually, I'm setting up the ground here. When we come into the future sessions, we are going to talk about how this data types is going to be affect directly on your machine learning world. And then, my apologies here, it's not data type, it's a variable category. It's really important, variable category, because we talk a lot about variable category in the future slides. It's a categorical values and continuous values, right? categorical and continuous category. So what is categorical? So categorical is something which you can classify, right? So you can classify a group of people with a gender, could be male or female, right? Or other. So that is actually categorical. So play cricket is a category because it can be two categories they said it, 0 or 1. We don't have any other category, right? So it can be play or cannot be play. So that is the reason I say that that's category. So colors, that's another good example, right? It's not in this case, but in the other case, colors is going to be another example. That's a categorical value, right? So all these are actually something which you can categorize in. And then why it is important is certain machine learning algorithm be specifically created for this categorical. And just want to mention that here, when we talk about categorical, when it's come to machine learning world, so we are actually using something called distance in the vector to identify the distance between those two categories, right? Call it as Euclidean distance. I'm not going deep there, don't worry about it. So the other one is called continuous variable. Continuous variables are always numeric, right? So it could be height or could be weight or could be mark in the sense of like, it's not grade. If you have a mark in the numbers or a number of sales, so all those revenues, all those are actually continuous variables, numerics. The important here is how we are going to treat continuous variable and categorical variables in machine learning world is different. Any questions on that slide? I think it's pretty straightforward, right? So let's move and let's see what is a univariate analysis, right? So we talk about continuous variable, categorical variable, and now we are going to talk about what is a univariate analysis. So at this stage, what we are going to do is we are exploring the variable one by one, right? So how we are going to have a method to perform a univariate analysis. That actually depends on whether the variable type is categorical or a continuous, right? So let's take a continuous variable. Continuous variable is what? Numerics, right? So continuous variables are numerics. So in numeric example, we really need to understand the central tendency and the spread of the variable. That means how it is being spread over the period of time. So this is, remember in our earlier slide, we talk about visualization is very important to us. So we actually creating certain functions in machine learning world. So I'll be chiming all these tips to you. So in machine learning world, we will be having a function called Panda functions. It's a library, Panda library. It's a Python-based library. So in Panda, there are a lot of functions by which you can plot it. So not only Panda, it's not limited to Panda. There are Panda functions, and then taking that Panda functions and type that to Matplot library. So that is another library which you can use it. So all this is going to be helpful to visualize how the data is being spread over the time, right? So there are certain methods we use it for that continuous variable analysis on univariate. That is when I'm saying univariate, we are going to take one single variable and looking at the spread. So this is going to be helpful to find out if any anomalies is going to be happen over the period, right? Spread. And what are the outliers, right? That is another good thing about by looking at that visualization. There are ways to do this one are median, central tendency way, how we can do a mean, median, mode, min, max. Those are the examples. And measure of dispersion. So how it is going to be dispersed over the period of time. It could be over the period of time, or it could be over the period of sales over time. Majority of the time, these kind of things are really tied with time, right? Not all the time, but depends on the situation. So how it is actually dispersed. Could be range or quartiles or variance, and standard deviations are a good example I can think about it. And if any of you, Lijan can talk more about this, apply for or attempt for certification, Liane or certification expert here. So this is one of a usual question. I'm actually a certified machine learning expert in AWS. A specialty. So if you go for that specialty cert, this is kind of a common question you can anticipate in a univariate analysis. What is a visualization method you use it? So the majority of the time, people be using histogram or box plot to find out that that's the visualization method to find out. It's a tip for you. But you got the one of the reason we are using it. And in categorical, so this is actually continuous variables case, right? But comes to categorical variables, so we cannot use this disperse method, right? So we cannot use this. So we probably need to use the bar chart there. So we are going to categorizing it. How many, for example, male and females you will be seeing too, if you have multiple colors of a specific product. So we'll be plotting based on a histogram, a bar chart, and find out how many reds are there. For example, if red is really showed up and all of them are really low, then it's going to be really a skewed data, right? So when you using that skewed data in your machine learning world, when you're training a data set, a skewed data set for training, your model will be biased. And when you put that in production, that will not be function well. Your prediction will not be right. So that's really important, how we need to get a balanced data set for doing that. There are certain ways to do it, called synthesizing the data set and such. Not going there right now, but beyond the scope of our discussion, but I'll come to that later when we are actually start thinking about creating models. So I'll talk about that later. So you get the idea of how we are going to visualize the univariate analysis here. Any questions? All right, so let's talk about bivariate analysis. So very important, bivariate analysis. And a lot of times we can see when you look at a Jupyter notebook in Sagemaker, you can see that bivariate analysis, but nobody is going to talk about we are going to do bivariate analysis, but you're doing it and you would be writing scatter plot to find that, right? So the reason for that one is to find out the relationship, right? So bivariate analysis is actually finding out the relationship between two variables or more, right? So here, majority of the time too, because it's a two-dimensional graph, right? So here we look for association, how these two variables are associate each other, or how it can be disassociated. Could be a reverse order, it's an inverse proportion, right? So that variables are actually in a predefined significance level in that case, right? So when you perform that bivariate analysis for any combination of a categorical or a continuous variable, right? Can be multiple combinations possible. That combination can be categorical, or a categorical continuous, or continuous. So two continuous variable, how that correlate each other, or a categorical value or continuous variable correlate each other. So the benefit is if there is no correlation between those two variables, that means we consider two features. We can drop that feature, because if you increase the dimensions of your feature set, your model becomes complex. When your model becomes complex, you are actually increasing your training time. Your complexity of the model increases with no with no better outcome, because there is no relationship, and it's not affecting the prediction at all. Then why we need that feature to be there? We cut it off. We can remove the dimensions. That is called dimensionality reduction. There are certain machine learning method itself using for dimensionality reductions. So this is a reason why we are doing this bivariate analysis. That's very important to understand why we're doing it. You need to always ask that question, even in your life too. Why I'm doing this? Is there something, a purpose behind it? Yeah, that is the purpose behind it is we need to reduce our training time. So that means if you reduce your training time, you save money, because you save less for your compute cost when you're training time, and faster to the market, less complex and more predictability. It's always good. So it's so many benefits you're going to get out from that. So then I'll go to the next slide and explain that a little bit here. So what is a continuous bivariate analysis? So when we doing this bivariate analysis between these two continuous variable, right, we should look at the scatter plot, right? So we plot between those two variables and find out the correlation between those two. And whether it is a strong positive correlation or a moderate positive correlation or no correlation. But think about this way, right? So if you have multiple continuous variable and you have you will be finding out what is less significant continuous variable and more significant continuous variable, right? So then we find out end of the day, one is actually very less more the significance on your prediction over the period of time, then that dimension we can cut it off. That conclusion will reach based on this analysis what you're going to do here. That's the important thing. And the same thing, strong correlation and then negative correlation can be happen too. So all these are examples of how that correlation happens between continuous and continuous. And I actually took an example for you. This is going to be when you're going to Matplot library to use that to show that correlation. So we can use this. I mean, this is the way they use it in Matplot library. So no worry about the data frame. Data frame is actually creating basically based on the data set, you can create a data frame in Matplot, and you'll be creating operations on the data frame. So that what you're internally going in when you're going to do by using pandas or Matplot libraries. So it's finding the correlation here. So CORR function correlation. So you don't need to too much go into the details of math behind it. If you understand things and you know what function you need to use it, and you can use that function in your programming library and use this getting this done. So you don't need to go and get a master in statistics before we start your data science day.
Excuse me, Shivu.
Yeah.
I just have a question on your previous slide.
This one or this
bivariate, yeah. Okay. So what you meant is for bivariate is for two variable, but we also multivariable. We can also mix and match categorical, and continuous, something like this. Did you mean that?
Usually we do two-dimensional analysis because when you're going to do a scatter plot, so we would be having how we are going to correlate two variables. So that can be depicted on a scatter plot model, right? Scatter plot graph. If you go with multi-variable analysis at the same time, so we would be increasing the dimensionality of your graph. The visualization is going to be more complex in that case, but it is doable. I didn't dive deep into that areas, but majority of the case is going to be fall into this. But what people usually do is we'll be doing multiple combinations of those.
Okay. Thank you.
That's what I have seen so far. But definitely possibilities there, because when we go into a bigger analysis world, there are specific tools which is going to be helpful for you to do this multi-variable analysis at the same time with the different techniques. So one of the tool I was thinking about is about, you heard about SAS tools, statistical tools. It's not SAS, software as service. There is something called SAS. If anybody know about that, that's going to be an advanced statistical tool people usually do. It's an expensive tool, but a lot of organizations use SAS for that statistical analysis. Does that answer your question?
Yes, thank you.
Okay.
Okay, I have another question. Like I have multiple variables. So in that case, I have to do run any types of dimensionality reduction techniques so that I can do the bivariate analysis. Am I right?
Yeah, before you come to this dimensionality reduction, right? So you can use something called PC.
Right, PCA. Huh?
Yeah, so you can use PCA for dimensionality reduction, by which machine learning itself going to be help you. But what exactly PCA is going to do is it's going to be creating that vectorization and finding it out whether it's going to be coming under the same directions, right? What are the dimensions which is coming under the same directions that can be they categorize as the final variables and cut it off rest of the stuff. So basically, it is doing that level of significance, and based on this, based on that algorithm, which is going to be do right. But before you pass that into that model, you can do this bivariate analysis by this visualization technique by yourself. So you can remove very obvious features which does not have an effect on your feature set at all. You can cut it off earlier and then use dimensionality reduction. The good thing about that one is when you use that, for example, you have 100,000 features, right? And you use that 1,000 features and you do that analysis and cut it off around 50% of that, right? Just picking up a number. And then you use that PCA analysis at that time. Your time to get the final result may be much faster in that case. And you can save the time on the training as well, right?
Okay, got it.
That obvious cut it off part, right? Obvious pruning can be done by your bivariate analysis, by statistical method, by the kind of this scatter plot method and such.
Okay, so if I do the pruning by myself, so yeah, is that maybe I already eradicate the important features from my set, but if I do that by PCA, then maybe I can get the better features.
Yeah, of course. So if you can use that, I mean, as I said earlier, right? So you can, the obvious thing, cut it off and then use PCA to get more granularized or better clarity on that, right? So that's the benefit you're going to get if you do that obvious thing, cut it off. So something which is really low hanging fruit, you don't need to rely on your PCA model to cut by itself, right?
Okay.
Especially when you have a lot more feature, then it's going to be because it's a shallow learning algorithm, and time is going to be taken a little bit more on that side. So otherwise, you need to increase your CPU power, right? I think it is a CPU based algorithm. I don't think it is a GPU based, I guess.
Right. 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 Thank you so much.
All right. I love that involvement. That's really good. So let's keep challenging ourselves. All right. So next one is categorical.
Yeah. Shibu, just wanted to add, right? So see, I think when you run into machine learning scenarios, right? You have data, right? You have a data from different sources, and as a data analyst or data scientist, whoever it is, right? That role, you are analyzing the data, right? So first you need to analyze the data. What is this data is for? What I am trying to do with this data? What I'm going to predict? And so you own the data, go through the data, and at that point, you are not looking at machine learning world, right? You are going through, run through Python, Matplot, all these libraries, plotting the data, creating the scatter plots, you are creating the box chart, all these things, different charts, and you analyze the data. So you become the owner of the data. At that point, you will find out how many variables are there, how many continuous, how many categorical, all these variables are there, right? So you know better than anyone else there about the data. So you need to own the data. Now you are at a point where you are confused about one of the categorical parameter, right? That is where you take a PCA, principal component analysis, and run through the data and see what that algorithm says that to you. right? So it's all, as Shivu mentioned, right? It's all input, output, analyze the output, feed that output back into the input again, analyze the output. And if you are not satisfied, take that output back into the input and analyze the data again, right? Now, if you are not happy with the PCA, use some other algorithms, right? So at the end of the day, you are working on a business outcome. You are asked to do some prediction, for example, right? And you need to make sure that your data or your model, end model, is predicting the correct result, right? So the more important in the machine learning world is that whoever is running the algorithms in any tool for that matter, you own the data, you should know the data very well, right? So I just want to make sure that that's a difference between normal programming language versus the machine learning, right? In normal programming language, you have an input, you write a code, you create the output. You're not taking the output back into the input and formalizing, right? So in machine learning world, you are continuously inputting the output data and find out the optimal point at which you can predict your output. So anyway, thank you, Shibu. Just wanted to add some color over there if I can. Thank you.
Sure, anytime. All right, let's look at the categorical and categorical, right? So there are ways we are going to do categorical and categorical. Some of the stuff I will mention here, but some of the stuff you can definitely go back and read about it in detail. So there are ways we can analyze that categorical and categorical. I said that categorical is more towards the classification side. So you guys know that now, or probably some of you guys know that earlier. So relationship, actually, by creating a two-way table of count and count percentage, what that means is how many of the count of category A and how many of the based on the total number and how many percentage of one has been counted, right? For example, I have 10 products and we are looking at the color of that, and 10 the red is 2% of the total 10 and blue is 5%, like that, right? So that is actually a two-way table approach. And another one is, to be honest with you, I saw that actually the two-way table people created by using Panda data frame when they are actually looking at that categorical. Another one is called a chi-square test. Chi-square test is, you can go ahead and read about it, but it's a little bit more complex about it to get the probability of indicating both categorical values are dependent, or it is a probability of one, means it shows that both variables are independent. And then there are certain formulas there by using certain formulas in the case of number of row total, number of column total divided by sample size and such. So you can definitely go and you can go ahead and read about why chi-square tests need to be used. The benefit is actually it's derived as statistical significance of relationship between the variables. That's the core part of it. And it's actually test the evidence in a sample is strong enough to generalize that relationship in a larger population. Very important statistical world, chi-square test. Many people do that. And it's actually based on the difference between the expected and observed frequencies, how many times an occurrence has been happening, right? I'm going really statistics here. And more categories in a two-way table. So that's all about that chi-square test comes in. But I would say it's worth to take a shot and go ahead and read about chi-square test to when to use it. So it's the purpose of doing that one is to find out the statistical significance of that relationship between these two categorical values, between any categorical values, right? And then the next option we used is stacked column chart. So this is very common, right? So we are actually charting it in a very visual method to find out what's the proportions of this. The example I use is small, medium, and large in a t-shirt. So what's the proportion of this? In a product 4, the proportion 86% is medium, and 4% or 6% is large and small. So majority is actually in the medium segment. So when we look at that specific product, that product is very correlated between the product 4 is have a very strong correlation between the categorical value of the medium size. That's important. We are going to do it. So if you really look at, you can tell me, oh, that data is skewed. Majority of the products being created based on medium, but you need to look at the other side of it. So the people who are that specific product, the segmentation, if you take the segmentation of that data, right, or segmentation of that category, majority of the people are in that medium size. Very important when we are actually creating a manufacturing of anything, right? So we need to find out that it's going to be improve our production manufacturing capacity, how we are going to inventory management. Everything is actually tied up with this. So think it this way. When I'm going to look at this problem, how I'm going to take this problem and apply in my business, right? And how it is going to be affect my revenue. How I'm going to make an impact in the industry or in the society, right? So think in that direction. That's going to be, it's a fun thinking process to me, right? So there are certain ways. I mean, I just put some examples here for pipeload library, how we are going to do it. So it's a group by function. We use it, and based on that, how we are going to stack it. That way we are actually explain that code here. So you can, there are multiple code snippet. You can see it, how we can use this stacked column chart. All right. So now let's go to categorical and continuous. So in categorical and continuous, while exploring that relationship between that categorical and continuous variable, we can actually draw box plots for each level of categorical variables, right? So if the levels are small in number, it will not show the statistical significance, right? So it's actually finding it out, statistical significance of this categorical and continuous variable, when the correlation between those two. So that's what we are trying to do. So there are certain ways we can do it by C-test, T-test, ANOVA. Those are actually a common way of doing things. There are, formulas for that for each time. I mean, for all these different methods, and you can find out the functions which is available in Pandas or Matplotlib or whatever it is, the libraries which you're going to use it. So you can definitely use that function to find out. So the important is why we really need to do it. So you find out this a categorical value and you find out another continuous variable, then you need to know that, hey, I need to apply C-test or a T-test to find out the relationship between these two. So this is going to be helpful to me. So that's important of it. All right. So anybody need so we actually reach an hour. So anybody need a 5 minutes break? First call for break. Anybody need a break?
Yes.
There you go.
And you need a break as well, Shiva. 1 hour, right? You're talking.
Let's take a 5 minutes break. I also take a very short break. I'll be here. What's the time right now? So it's 9:09. We'll be starting at 14 or 9:15. We'll start. Is that fine?
Yeah, sure.
15,
All right.
yeah. Okay.
All right. So let me grab some water and come.
space and how to think in image. Is it?
So are we back? Are we back? Can we start now?
Sure. Yeah, I think most of the people are online. Thank you, Shubho.
Okay. Thank you, Lijan, for checking it, because I'm not seeing the the participant screen here.
Correct. Yeah, that's right. Yeah, I'm seeing.
And also, Lijan, you'll be looking at the questions as well. Anything comes up, right?
Yeah, that's right. Yeah, I'm looking at the chat closely. Correct. Thank you.
All right. So now let's start. So remember the box diagram, which we have it when we started that. So the second thing is the missing value treatment. So I'm actually planning to finish feature engineering. I think it is a little bit dragging right now. So I'll be going a little bit faster. So we need to finish with feature engineering today. And the next session, week or two, we can arrange the next one, which is going to be talk about the algorithm part of it. All right, so let's talk about missing value treatment. So what is missing value treatment? So missing the data in a training data set can reduce your power or fit, you call it, of a model that can lead to a biased model, right? Because we are not analyze the entire data set behavior in that case. And we are not, or with less number of data or missing data, we cannot find out the proper relationship, right? So which we talk about the correlation thing, which in earlier slides, so which we cannot do it. So missing value treatment is really important. So why it is required? Because it's reduced the fit of the model. That's very important thing, because that's the purpose of the thing is, when we talk about fit, means how well that model fit with your data set, right? So how better it fit with the model, there is a certain caveats there, but we will talk about that later. How well it's going to be fit with that model is going to be how much better the predictability and accuracy of that model can happen. Not all the time, again, caveats there, we'll talk about that later. So, but in general, that's the rule, right? And again, if missing values are there in your data set, which you're going to use it for your input, so it can be leads to a biased model, right? Because we couldn't identify that entire relationship and behavior of the data with what you have, right? Because of the missing values, and can be definitely leads to a wrong prediction or classification based on the model which you choose based on your business needs. And so let's talk about why the data sets are majority of the time is missing. There are there are reasons for it, right? Remember when we talk about when we are extracting the data and transforming the data to our feature store, right? Or consider that as a feature store, you're getting it. So at the time of data extraction, it may be possible that there are problems in the extraction process. So we miss some of the data. Or sometime transformation got failed and we have a safe exit in your transformation logic, right? It won't be error out, but it will be keep proceeding it. But that certain elements may not be processed. It's going to be leads to missing data. And at the time of data collection, that's another important point, is there are multiple ways that data can be missed in a data collection process, right? It could be completely in a random basis, or it could be missing at random. So there is a difference between those two, right? So in case when the probability of missing variables is the same for all observations, or it could be different, right? So for example, if you are taking a survey, right, the respondents of the data collection process can decide not to say that, right? And some of the people may not say it, some of the people say it. And missing at random is for example, when you are taking the age information from a population, right? A population means a certain set of people. We are collecting a sample set. And from that population, you're collecting the data. And ladies may not be saying their age sometimes, right? Or some men may not say the age. You guess, right? They just for making fun, you guess, right? So those are actually missing at random examples, right? And then it can be an unobserved predictions. So some of the stuff we cannot observe it, so we purposely miss it. So all these things can be happen. So this data missing process. So it is. I mean, why I'm saying this one is, it is inevitable that data may be missing. So we need to equip to treat these missing values. So the one more other thing I would like to mention there is, we cannot fix the root cause of that issue. That's the most important thing. So we have to have a preventive mechanism. Once it comes back, how we are going to treat that missing values. That's important. So how we can treat that method? What are the methods we can treat that missing values? So one is actually deletion. So there are two ways of deletion. One is called list-wise deletion, and the other one is pairwise deletion. List-wise deletion is pretty straightforward. Both are straightforward, actually. List-wise deletion is we delete the entire row. So can you tell me the disadvantage of list-wise deletion? So you delete the entire row and you have so many missing values, your data set is going to be really small, end of the day, right? So you'll be go with a very small data set for your training. That may not be a good idea, right? The pairwise deletion is, we will be looking for the significant values are there. We will keep that row, but we don't worry about that missing value, what it is missing, so we will replace with something else. Something else is actually coming up in the middle, right? So that is actually a pairwise deletion. And then we have imputation technique. So the deletion technique is one. So we will be deleting it, the entire row, or less significant values we find out, we replace with something else, or we delete it. That is an option. And another one is we impute. So imputation means to fill the missing values with an estimated one. That estimation can be different. It could be by using a mean or a mode or a median imputation. Those are actually different than that. So for example, you have sales data. So if you are having a missing data, then you can take the mean of the previous one and the next one and find the middle of those, and that can be replaced. So sometimes people will be using sorting method before they do that imputation, right? So there are two ways we can say that. There are generalized imputations and similar case imputation. Similar case imputation is more towards finding it out, that similarity of this specific rows, and that could be this, it could be same thing here. So we can replace that missing values with the similar one we find out, and we can replace that as similar case imputations. So generalized case imputation, we are actually calculating the mean or median for all that known missing values. Then we replace that missing value with that mean or median. So that's another way of imputation. Then there is something called a prediction model. So, when we talk about prediction model, it is a little bit different. So prediction model is actually more sophisticated method of handling the missing data. So where we are actually creating a predictive model. So we are actually doing a machine learning model to estimate the values, and then we'll substitute the missing values. It's a little bit more sophisticated way, more cumbersome too in that case, right? So you probably need to take that certain set of variables. So you need to have some kind of bivariate analysis earlier before we are taking that certain subset out from your entire set, before we are doing that prediction model imputation method. That's important. Its KNN imputation is, again, going back to this, again, machine learning model. So in this method of imputation, actually missing values is an attribute that are imputed using a given number of attributes that's the most similar to the attribute where the values are missing. So there are, as KNN, it stands for K nearest neighbor. So it's basically, it's actually using Euclidean distance between these two multiple missing values and find out what's a possible distance to that, and finding it out that similar distance and getting that value and impute that. So that's what it's going to candidates do. But there are advantages and disadvantages for that. So so one of the advantages, a few advantages I can tell you is that k-nearest neighbor can predict both qualitative and quantitative attributes. That's actually good. So we don't need to, so it can be both categorical and continuous variable. It can predict in that case. And the other one is like creation of predictive model for each attribute within missing data is also not required in that case. And disadvantages, so it's a very time consuming in analyzing large databases, large data sets. So it searches through all the data sets and looking for the most similar instances. Again, it is a shallow learning algorithm. So it will be, the time is going to be a matter there, because there is a certain ways, only certain level you can increase the compute power for that. So you need to be vigilant on which method you're going to choose it for this imputation, based on your time to market and based on your compute power, which is allocated to you. It's important there. So now let's talk about outlier detection and treatment. So let's talk about what is an outlier, right? So probably all of you know that what is an outlier. So outlier is actually commonly used terminology in analytical world, right? So when any observation that appears far or diverge from overall pattern, right, in a sample. So it's actually really make prediction biased, because as I said in an earlier example, between 5 and 10, that is kind of a significant level. And then if one is actually coming out at 100 or 500, so that's going to be a complete anomaly. So the options are finding it out why that happens, and can we cut it off, right? So, or any other method, if that's a legitimate, then we probably may need to treat it. So let's talk about how to treat it. So increase the error variance and reduce the power of statistical test, or I mean the why to treat, right? So so it's going to be create that variance and reduces the power of statistical test. That's one of the reasons we need to treat it. And but when it is randomly distributed, right? So they can decrease the normality. So that's another reason we need to treat it. And the other reasons are biased and influence the estimate when it's going to be when we are going to train that data set with that kind of outlier. Without treating it, your inference would be completely biased. So it's very important to treat that because of these reasons. And how we can detect, it's very easy to detect. So we can use box plot, histogram, and scatter plot. So you can see that how it is going to be completely throw out from the entire population, right? So where the most significance going to be there, and one is completely jump out from the box plot or histogram or scatter plot. So you can identify how many outliers are there. So if just one single, I mean, this is very important. So if there's only one outlier, right? So go and find out what's the reason for that outlier. Maybe a wrong observation. So we can cut it off. So we don't need to spend time to treat it. If there are a bunch of outliers, then we start thinking about we need to treat it. So creating that sense, that's important, right? So that's the reason I actually thinking about teaching about feature engineering is really important before you're going to take the next step in machine learning.
Sorry, can you repeat the part where you said if there's one outlier and if there are a bunch of outliers, well, what is the difference?
Right. If one outlier, for example, you have a data set of 10,000 observations, we find out, and we scatter plot that, and then we find out there is one single dot completely outside that the entire green area where it's clustered, and one is completely outside, along outside, right? So we find out it's only one. So then we can find out what observation, what specific observation create that outlier, right? So go and find out that observation and probably work backward from that and find out why that observation is an outlier. It could be, you probably find out a reason that may be a wrong observation, or could be a human error. Somebody entered that data in some point, or some of the transformation logic being failed during that analytics process, right? So in that case, you can simply cut that off. You can take it out because you don't need to incorporate it because it's an erroneous data, erroneous observation, right? So you can remove it. So there is no brainer, right? But if you find out in a 500 or 1,000 number of observations, there are 100 outliers, then we cannot call those are really outliers. There are 100 observations that legitimate, but it's actually far from the clustered area, right? So then we need to start thinking about how we are going to standardize and normalization. So I'm coming to that point. It's not part of this, but we'll talk about normalization and standardization here. But that is the outlier treatment comes. So at that time, we cannot cut that 100 because those are legitimate. At that time, we really need to treat it. When you need to treat it, we need to identify it, and then we need to have a method how we can treat it by generalization, normalization. Does that make sense?
Right. Thanks.
All right. Awesome. All right. So now let's come to feature engineering. So now we are actually look at many of the areas which we talk about, variables and how to treat it and how to handle that, the whole thing which we did. Now we're coming to feature engineering. So feature engineering is actually a science, right? It's extracting more information. So there is, anybody can tell me about what is the difference between information and a data? Anybody know that? What's the difference between a data and an information?
I think data can be anything, but information is something specific.
Right. What's the correlation? So we talk about correlation so far, right? So what's the correlation between information and data?
Maybe data is all things. The information is the useful things.
Right.
Yeah.
You're right. Yeah. So data itself, it's not an information. When data combined with another data, I mean, not all the time, but when data combined with another data, it's creating information. Sales, we say that 200 units sold. That's a data. Does that make any sense when it comes to business? 200 sold. The first question your CEO asks, when? Over what period? Right? So time correlate with sales, right? The time is a data and sales is a data. Those two data come together, combined, creating the power. That power is information, right? So that's the reason the whole data world is amazing. When we are creating, how we are actually creating the value out from the data is most important part of the data analysis. That's the reason it's become an engineering or it's become a science. So anybody can look at the data. Okay, great. So we can slice and dice. We always say that slice and dice the data, analysis and paralysis. But that is not going to really create the insights of the data. So to creating that insights of the data, we need to know that the fundamental functional level knowledge, how to slice it, how to dice it, how to do the analysis, how we need to combine this data to create more and more information out from that. That's the important thing. That comes to feature engineering. So that's the reason feature engineering became a science of extracting more information from the existing data. It can be not by adding any new data, but making the data which is already there and making it more useful. And that time, sometimes the data we collected does not make an information out from the data. We need some external data to come to make that existing data points to become an information, to flourish to an information. So at that time, we call that augmenting the data. Augment the data to become an information, right? So that's very important. So the process of feature engineering is, we discuss about variable identification, univariate, bivariate analysis, missing value, imputations, outlier treatment. All these are actually process of feature engineering. So we are actually one step closer to our machine learning world, right? And two things which I'm actually talking about right now is variable transformation and variable and feature creation. That is another two things which is two things which is really important. So let's talk about variable transformation, right? So an example is, so in a data modeling world, the transformation refers a replacement of a variable by a function. That is a transformation. So it's same thing with the data transformation too, right? So we have a function, we take that variable and we will reform that to a certain different fashion, right? To what the way we need it. So for instance, replacing a x by a square or cube root or an algorithm of x for a transformation. I mean, when we talk about the cube root and square root and algorithm variable transformation, actually creating a segue to talk about standardization and generalization, especially going back to an outlier we talk about, an outlier treatment, right? So we'll be we are actually normalizing. The log method is one of the normal way of normalizing the data set. The other one is actually variable or feature creation. So variable and feature creation is, you have variable. So I mean, let me go to the next slide. So I don't want to. So in variable transformation itself, we need to talk a little bit more about it. So one is actually a replacement of a variable by a function, which we talk about. The another one is called encoding. So two kind of encodings. It could be more than that. So one of the two main things are integer encoding and one-hot encoding. So integer encoding is, for example, true or false. You say that true and false, and you change that to 0 and 1. So it's one of the best way I can tell you that it's an integer encoding. It's an example of integer encoding. Then then other one is one-hot encoding. One-hot encoding is kind of a normal jargon which you can hear it in machine learning world. One-hot encoding. There are functions to do that. So the reason for one-hot encoding is when you have categorical values, right? So for example, colors. So we have a product, and that product is come with 5 different colors: red, blue, black, orange, and such. So you write all those colors when you collecting the data set from your observations. So those are the colors you have seen, but you cannot use that colors as is to machine learning model. Exceptions are there. There are certain XGBoost algorithms, they take characters, I guess, but majority of the time we prefer numerics, right? Better performance too. Numerics because it's easy to vectorize and easy to understand the machine as well, right? So always numerics prefer in that case. So how we can convert that to numeric? So when we convert that numeric, there is a challenge there. So one is actually you can use integer encoding there. So that's one option. And another option is one-hot encoding. So integer encoding in that case is we are actually replacing orange with 1, blue with 2, and like that, right? Other one is, so we take that and, what is the right word for it? Transform that to that column to rows, right? And expand it. I don't have the whiteboard to write. Otherwise, it's something which really illustrate with whiteboard. So then you say that the product X, and you write that instead of that column, red, blue, orange, and those, you write it, as a rows, you write it as a columns. Red, orange, blue, those are columns. And that product is going to be 1. You add 1 for orange, that means its color is orange, and red, blue, and all other colors become 0 there. You get my point? I know it is a little hard to explain it by words instead of drawing it. So I would say, go ahead and search about one-hot encoding. So this is a concept. So if a column is there, you take that column, and the values inside the column, you make it as, mistake. The entries in that column, the color column, right? So red, blue, orange, and those. So you take that entries in the column and make that as the column header, right? And then you mark that product. This is red, then put a check mark on red, and rest of the stuff becomes 0. Instead of check mark, you use 1. That makes sense?
If I add something here,
please.
You are telling in this slide that when you transform variable, you are actually doing the conversion of categorical data to numerical values, right?
Correct. Yes.
With this integer encoding and one-hot encoding techniques.
That is
right?
correct. Yeah.
All right. Thank you.
All right. Exactly. So I'm just trying to explain that one-hot encoding because it's without illustration. It's a little bit tough, but I did the best I can do on that. Definitely, it's worth to check it how it looks like.
Shibu, I just posted that screenshot of what you were talking about, like in terms of relating that red, green, blue with the row and column model. Yeah, so just
that's awesome.
Correlating to that.
Yeah, it is. It's really hard to talk and put the right paint on that picture, right? So it's actually the process that changed the distribution or relationship of a variable with others. That's what exactly the variable transformation is. And when you need to apply this, so change the scale of the variable. So it has to be in the same scale. For example, Outlier is a good example. So it's all different scale. Then it's going to be becoming as a little bit more linear scale. So it's always better to be in a linear scale. That's actually a linear relationship, a non-linear relationship into a linear relationship. That's really important. That's actually good. So there are certain ways we can do it. So that's a place where we are going to apply this. And another one is
at the front door.
Sorry about that, guys. So another one is symmetric distribution or skewed distribution. So if skewed distribution is there, it's going to be, it's not easier to interpret. So it is the reason for a symmetric distribution is preferred over skew distribution is it's easier to interpret and generate the inference. So some model techniques actually require that normal distribution of variables. So that also a reason for why we need to use variable transformations. So variable transformation you are using day in, day out in the data science world. So common methods for variable transformations are the logarithm, square root, cube root, binning. Binning is actually more towards the categorical portion of it. So you created that in different bits. So that's actually, it's used. It's actually taking that performed as an original values and percentile or a frequency. So that decision of that categorization technique is actually based on business understanding how to bin it. So that's really important. The functional knowledge is important in that case. Feature creation. So how we are going to create, how we are going to derive the variables or creating the dummy variables. So that is actually part of feature creation, which I talked about that earlier. For example, creating that derived variables is good example is day of the month, month of the year. That is a really good example. You're breaking it down, right? And sometimes you form the variable by combining it. So that's two benefit of it, right? So if length is significant and width is also significant, then area can be significant, right? So that means, based on conditions, but in that case, when you're combining it, you're actually two benefits you're going to get it. Your significant level is not going to change. You combine length and width in this case. At the same time, you're reducing the dimensionality as well. So you're reducing the complexity of the model. So the double benefit. So think about where we can use that feature creation before we are finalizing the feature set for your training data set. Right, that's important. And creating dummy variables sometimes, which is maybe required. So the common application for dummy variables is to convert a categorical variable into a numerical variable. So that is something called indicator variables, an example. So that is actually part of the feature creation. All right, so now let's take a little bit detour. So how feature engineering in ML workflow? So you collect the raw data and then you do the feature engineering here, and then you create features out of it. And then we did the whole thing, which we spent close to 2 hours on this feature engineering. And this feature engineering is attributing to these features what you're going to get at end of the day. And we are using that features for model training. And then we are getting the inference, that's the business world, and we're getting the business outcome here. And then based on the new data set comes in for inference, we are passing that back to your raw data set, and we are doing the same cyclical process again by using feature engineering and producing more informed features, and the cycle continues. So that is a typical feature engineering in ML workflow. So now we'll look at that data preparation, how much time it's going to take. So based on the surveys, right? So it's based on the FOB surveys on 80 data scientists. So 80 is a population here or sample set here, right? It's basically same statistical analysis. So 60% of time we are actually collecting that, cleaning and organizing data, right? So altogether, that 80% of the work is actually data preparation part. It's multiple phases. So that's what it does, right? So the whole thing which we talk about is really, really significant in machine learning world. And not only significance, it's going to be a lot more value when you are going to build the model with that clear understanding of feature science. And that's going to help you a better data science person in the future, right? So now let's look at some common challenges with the data preparation machine learning. So one is time consuming. It requires multiple level of tools. It's require multiple data preparation tools that typically not really DevOps friendly tools. It's require a lot of writing codes. Depends on what you use. For example, if you use, I mean, as I said, all these feature engineering, we talk about different Panda functions, matplot libraries. And when we are creating that scatter plot, you need to write 10, 15 lines of code, maybe it depends, right? So there are a certain amount of work that is really involved to make that happen. So how AWS can help you on that? So let's talk about that. SageMaker Data Wrangler. How SageMaker Data Wrangler is going to be placed in your feature engineering world. So the benefit, I'm not going through Data Wrangler at this time, but I'm going to highlight this product, right? This service, how it's going to be useful. And then the future sessions, we can use Data Wrangler for your feature engineering work. So the main benefits, it's a new feature for Amazon SageMaker. It's actually enabled through SageMaker Studio that make it easy for data scientists and ML engineers to aggregate and prepare data for machine learning applications using visual interface. That's very important. It's not only visual interface, we do have APIs as well to accelerate the data cleansing, exploration, visualization. All that three things, data cleansing, exploration, and visualization, everything what we explained in our data, in our feature engineering class right? And address all aspect of data preparation needed for the ML. So you can quickly inspect and import data from multiple sources and leverage built-in transformations. It could be from different languages. It could be from PySpark, and build your own custom transformation by using SQL or Pandas or PySpark or Matplotlib libraries, whatever, right? And then visually analyze that feature and evaluate and iteratively improve the accuracy and quickly deploy that data preparation steps, right? That's a benefit you're going to get it. So the Data Wrangler is something new, but it's really, really powerful. And it's going to be really cut the time for data science people to do this one visually in the SageMaker Studio. You just drop downs, right? So you said that you choose the data set. It's coming from, you said that it's coming from S3 bucket, and you prepare that, and then you choose do a scatter plot on this two variables, doing a bivariate analysis. Give me a scatter plot. Boom, it's give you a scatter plot. You don't write any code. That's the benefit SageMaker Data Wrangler is going to bring in. Now let's talk about feature engineering at scale, right? So we talk about feature engineering. It's Data Wrangler is going to be help you to give you feature engineering capabilities, right? Then going at scale and ML productivity, how it's going to be affected. So we think about, we are actually doing an insurance claim, right? So we are actually collecting data from vehicle damage images, claims customers, and text interactions, and telemetry data from vehicles. So if we have a vehicle total loss model, then we are actually creating this different data engineering sites, right? The feature engineering and creating a feature store here and use it for vehicle total loss. And then another team in the same organization worked on customer churn, right? How many insurance guys are sticking with me? How many people are going out? So I'm actually analyzing it. They may be using this same kind of data. They may be leaving because they didn't give you a better service on vehicle damage data they collected, and they didn't provide that better coverage there or better claims there, XYZ reasons. So they may be collecting those kind of data from all these different points. Again, they're creating their own feature store and using it. It can be going on. You got my point, right? So how we can help them. So the challenges, it's going to be happening that scaling that ML productivity is in multiple areas. So to summarize, the ML productivity, that's a long and tedious feature engineering work. And it's going to be redundant feature pipelines are getting there. And there is no sharing or discovery mechanisms out there. And troubleshooting overhead, right? Going a little bit faster, so we need to finish it. A couple more slides, I guess. We are on time on that. In that area, we introduce SageMaker Feature Store. Another big bet on SageMaker platform So how you can create that feature store in a scalable perspective and reusing that feature store in a very secure manner, and it's fully managed, and you can discover and reuse that features once you created that. So think about the power we are actually putting together in one single platform by SageMaker, multiple tools. But here in this case, specifically, I choose these two services, which is very significant to what we talked so far about feature engineering, right? So we get the feature engineering and get this thing done. Everything is going to be in a well articulated, without writing bunch of code by Wrangler, right? So once we get that feature set, we need to store it and reuse it and version it and make it online and offline feature. And everything is possible by SageMaker Feature Store. So we'll be having some hands-on exercise in the future to talk about SageMaker Feature Store and Wrangler, how it's going to be putting things together for you, and how it's going to be how it's going to be help you to catapult your journey in machine learning world. So just a few things about feature stores. There are two features, like online feature stores and offline feature stores, where online predictions, it's going to be keep only very latest data, but the entire data set can be in offline feature store. There is a 15 minutes read after write consistency and append only model. So I'm not stressing too much on this. We can definitely go through that later on. There are multiple other options are like streaming injection to feature store by feature processing. This feature processing here, you can think about using Wrangler here, right? And then streaming injection back to our feature store here. It's going to be securely and versioning it and managed feature store there. And how feature store works, it's getting the raw data, and then feature processing will be happen here. So we can start thinking about the whole area. We can replace it with Wrangler in this case. But raw data to this injection, this line, right? This big line actually, even though it's showing as small. So here we can use other AWS services called Athena, Data Brew, Glue Data Brew, lake formations, and all that great services on data analytics part can be happen between these two. And here feature processing, Wrangler can become in play. And then come to SageMaker. Once a feature is ready, we are going to use SageMaker Feature Store to store it, and that in just the data, storing it and serving it for multiple teams. Depends on their use case, real-time inference or batch inference or model training and such. I think we passed the milestone 1. So that's the end of this. We have 5 minutes back. I will giving that time back to Mo. Mo, you have 5 minutes for a closing statement, please. If you have any other questions, I'm here. I can stay a little bit. Sorry, I cannot stay. I have time till 10. If you have any questions, I'm here to talk to you. Otherwise, turning back to Mo. Mo, you there? All right, he may be muted. So any questions to me? So we finished the feature engineering and we saw the tools which you can use it in feature engineering in AWS ML platform.
Okay, I have a question for you. Like when you were talking about the missing data sets, like I have missing data sets for my rows. So how much percentage of the missing data can be eligible to keep or to prone?
How much percentage? It actually depends, right? So we cannot say a number. It's actually depends on the data set size. So if you have 100 observations and there are missing data out from is 25, that's a significant percentage. So we really need to look at how we can impute that. That's one option, and another option is finding it out what that costs. I mean, for example, if that observation is based on some survey or something which you cannot go and fix it, But if you have some control over it, you can go and fix it. It all depends on the use case which you are going to handle. There is no specific number we cannot pick it, right?
Okay.
And make sure to finish the survey. তোমরা যদি না করে থাকো, you please make sure that you do it.
Sure, sir.
আরেকটা জিনিস, what we're gonna do, I'm gonna work with Shibu and Lijan. We're gonna come up, give you a, okay, take this first. একদম basic থেকে শুরু করে, একদম, if you know nothing about machine learning, where do you start? What are the foundation? What are the basic things that you need to know? We're gonna try to give you a curriculum for that as well. You know, we're gonna be talking all the time to you guys so that you can actually follow with that. Okay?
Okay, sir.
Good. তোমাদের আর কারো কোনো প্রশ্ন আছে? So we're gonna finish right now because the time's up. But let us know if you have any questions. Slack-এ তোমরা ওইখানে post করতে পারো. That should be good. Okay?
Sure, sir.
All right. I hope everybody enjoyed this session. I definitely think you guys are carrying some knowledge with you today, some takeaways for you guys. And big thanks to Mo and Lijan to assist this process and leading this process by Mo. That's really great. And we probably, Mo, correct me if I'm wrong, we are going to provide some Sagemaker resources for them to play around with it. Right?
Yeah. So I'm gonna, you guys all have the event engine access already. Is that right? Now the labs are already posted in the Slack channel. Have you, তোমরা কি দেখছো কোথায় ল্যাব গুলো কি করবা তোমরা? তোমরা কি জানো সেটা? Do you guys know?
No, sir.
Okay. So what I'm gonna do, give me 1 second. I have to jump on a call. Give me a second. I know Shibu, you need to go as well. Is that right? So
yeah, I do have a call right now. 10.
Okay, so I'm gonna give you this. আমি তোমাদেরকে মেশিন লার্নিং এর ওই যে Slack চ্যানেলে আমি দিয়ে দিচ্ছি তোমরা কি কি করবা। ওকে? পাইছো? এখানে 5টা জিনিস আছে। একটা হলো রিটেল ডেমো স্টোর and then 4 other things. Okay? Go test it out. তোমাদের অনেকে এটা করছো, যাদের কোয়েশ্চেন থাকবে তোমরা এখানে এই চ্যানেল এইটার আন্ডারে এইটাতে রিপ্লাই করবা। This thread, use this thread, okay? All right, good enough.
Thank you all.
Thank you very much. Thanks a lot. Take care.
Talk to you later. Bye-bye. Bye all.
Thank you, Shivu.
Thank you. Thank you all.
Okay, bye.